Now we are looking onto the continental drift theory. Continental drift theory was proposed by Alfred Wegener in 1912. So in 1912 we have the continental drift theory, and it was proposed by the Alfred Wegener. So continental drift theory was proposed by Alfred Wegener. It was a revolutionary theory. Meteorologist. He was a meteorologist, one who studies about the climate, right? Studying changes in the world climate. Changes in the climate and are due to two possibilities. When does the climate changes? Climatic zones are changed. We have no proof because the tilt change only causes a shift. So shifted north or south, right? We observe that there is a climatic change. Climatic zones have been changed, but only a tilt in the change could cause such a climatic zones shift, right? But how does the continents have experienced various climates? It is because the continental land masses have moved. Continents shifted up and zone. Proof is possible. So we have the continental drift theory. Initially, there was a single continent which is called as a Pangaea, and a single ocean called as a Panthalassa. Panthalassa. Initially, we had the Pangaea as a single continent. So what is Pangaea? Pangaea is a single continent, and then we have the Panthalassa. Panthalassa. Panthalassa is nothing but a single ocean. So Pangaea and Panthalassa. Now it is the Alfred Wegener continental drift theory in 1912, right? The top layer is made up of the lighter elements is Sia. Below the Sia we have Sima, and below Sima we'll be having the knife. Sial is where all the continents are present. Sima is the oceanic bottom, and knife is the core region, right? So the top layer is made up of the lighter elements. The lighter element is called as a Sial. So the top layer, we say that the top layer is made up of the lighter elements. The top layer is made up of the lighter elements. The lighter elements is called as the Sial. So the lighter element is called as a Sial. Below the Sima is present, we have the knife layer. So knife layer is below the Sima. Sial, Sima, and then we have the knife in the down. So Sima is where we have the oceanic bottom. Sial is where we have all the continents, and knife is the core. Now Sial is floating on Sima without much resistance, right? Because the thermocol it floats on the ocean without any resistance, because it is in terms of the density it is much lesser. The theory is during the Carboniferous is where we be having cracks, development of the cracks and submergence, right? During the Carboniferous. Paleozoic era. The Paleozoic era had Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and we have the Permian, right? Now, in the Carboniferous is where we'll be having the cracks in the upper layer of the earth, right? So this theory begins with the Carboniferous period. The Carboniferous period is 225 million years ago. So 2 to 5 million years ago. Only year which we should remember with respect to continental drift theory is 1912 is when Alfred Wegener proposed this theory, and same 5 million years ago. And we need to remember Carboniferous is when the cracks appear during the Carboniferous, right? So 2 to 5 million years ago, Carboniferous. 2 to 5 million years ago, Carboniferous. There was a supercontinent called as a Pangaea, and then we have the Panthalassa is the water body, right? And every continent was connected together into a single landmass. Now, 250 million years ago, there was a equal crack, right? Huge rift cracks, and in between Pangaea has broken into two parts called as a Laurasia and Gondwana. So we have the Pangaea. Pangaea broken into two parts called as a Laurasia, and then we have the Gondwana. So Pangaea is divided into two parts called the Laurasia and Gondwana. Laurasia and Gondwana. We have Panthalassa, right? In between them, the Tethys Sea got filled into. Now, Laurasia is going to have Asia, of course, Asia, North America, and Europe. The South America, Africa, India, Antarctica, Australia, Madagascar are in Gondwana. So, what did Laurasia contain? North America, Europe, and Asia. Now, what did Gondwana contain? South America, right? And Europe, near to Europe, we have Africa. So, South America, Africa, Madagascar, Africa, and then we have the Madagascar, right? Now, we have India. Now, at the bottom, we have Australia, and Antarctica. So Australia and Antarctica. We have Madagascar and Australia, Antarctica, right? Laurasia, and then we'll be having the Gondwana. So Laurasia, and then we have the Gondwana. Tethys Sea in between. So in between we had the Tethys Sea, Laurasia, and then we have the Gondwana, and this is a Tethys Sea. Now Pangaea Panthalassa in 250 million years ago, there was a crack, or we call it as a rift which divided it into two halves. North America, Europe, Asia is Laurasia, and Gondwana is South America, Africa, Madagascar, India, Australia, Antarctica. This is 150 years ago when the two was separated, right? The Tethys Sea is between Laurasia, and then we have the Gondwana. Now, even there was a India is in the South Pole, right? North South rift. North South rift. Previously, there was a West East rift. Now we are having a North South rift divided the east and west of the. So, this North South is dividing the east portion and the west portion of both the Laurasia and Gondwana. The North South rift is dividing the east and the west portion of the Laurasia and Gondwana. North America moves to the west. India here, because of this north south drift, India is moving towards the north. Asia and Europe has joined together in the east. South Asia, America is moving towards the west. This is 100 million years ago. So 250 million years ago, we have Pangaea, Panthalassa, right? 150 million years ago, there was a crack which divided Pangaea into Laurasia and Gondwana. Then we also have Tethys Sea in between the Laurasia and Gondwana. Now, 100 million years ago, there was a north-south rift which divided the west and the east of Laurasia and Gondwana. North America moved towards the west and India towards the north. Asia may be having Asia, Europe in the east. South America in the west and 100 million years ago, right? Present Antarctica is in the down and Australia is in the east. Now, Alfred, what caused the movement? He was unable to explain what has caused the movement, right? The continental drift theory was proposed by a German meteorologist to explain the variations in the Earth's climate. He was a meteorologist who studies about the climate. Why did he propounded this theory to explain the variations in the Earth's climate with respect to the regions? Right? Why there was variation in the Earth's climate? First is the cause of the variations is that if the continents remain stationary while the climatic zones is going to be changed, the climatic zones are remaining stationary while the continent might have displaced. Wegener did not found evidences of changes in the climatic zones. Therefore, he proposed that continental drift is a reason. Either the continent must be stationary, or he mentioned that the climatic zones are stationary. Either the continent in itself is stationary. So the continent is stationary, or we say that the climatic zone is remaining stationary. Right? The continent is remaining stationary, or the climatic zone in itself is remaining stationary. As did not find evidences for the changes in the climatic zones, he proposed the continental drift is the reason. Assumptions by Wegener is he proposed three layers of the earth. Outer layer is Sial, intermediate is Sima, and the inner layer is Naif. Sial was a continental landmass, whereas Sima was an oceanic landmass. Sial masses were assumed to be floating on Sima without any resistance. Right, we have the continental drift of the plates. 250 million years ago, there was only one supercontinent called as a Pangaea, and a superocean is called as Panthalassa. Pangaea. All the present continents are merged together. This supercontinent started to split during the Carboniferous period into Angara land or Laurasia and Gondwana land. The northern part is Angara land, consisted of the North America, Greenland, Eurasia without India and Arabia. The Gondwana land consists of Africa with the Arabia, South America, India, Australia, Antarctica, and Madagascar. Gradually, north-south drift separated the North America and Eurasia, South America from the west, from the Africa, and which started to move towards the west. India started moving towards the north. Australia got separated from the Antarctica and moved towards the northeast. And 20 million years ago, Arabia got separated from the Africa and merged into the Asia. The forces suggested by Wegener are for the north-south separation. There are forces responsible for the north-south separation, and also the forces responsible for the east-west separation, right? North-south. The continents are moving towards the north, and then the continents are moving towards the south, right? North-south movement. The pole fleeing forces. The continents are attracted towards the equator. Pole fleeing, you move away from the poles. You are moving away from the poles is what we call it as the pole fleeing forces. North-south movement is because of the pole fleeing forces. You move away. We say that we are moving away from the poles. Move away from the poles is what we have. The north-south movement is when we are moving away from the poles is what we have the north-south movement, right? So the north-south movement is when we are moving away from the poles. So when we move away, when we are moving away from the poles, is what we have the north-south movement is when we are moving away from the poles is north-south movement is called as a pole fleeing force, and the continents are attracted towards the equator because of the buoyancy force, and then we have gravitational differential force. Continents are attracted towards the equator. This is because of the buoyancy force and gravitational differential force between the equator and the poles, right? Pole fleeing force, the north-south movement is because of the, we say that the north-south movement, it is moving north or it is moving the south because of the pole fleeing force, right? It is fleeing away from the poles. So the north-south movement, you move away from the north or you move away from the south. This such a kind of a movement is because of the pole fleeing force towards the equator. This is because of the buoyancy force and gravitational differential force. Because of the buoyancy force, and then we also have the gravitational differential force. Gravitational differential. Because of the buoyancy, and then we have the gravitational differential, right? So because of the buoyancy, and then we have the gravitational differential. So because of the buoyancy, and then we have the gravitational differential is responsible for the north-south movement. Now west-east movement is because of the tidal force and gravitational pull of the sun and the moon. Earth, we'll be having west-east. It is because of the gravitational force. Gravitational force, or it is also called as the gravitational pull of the sun and the moon, or it is also called as the tidal forces. So this is because of the tidal forces and the gravitational pull of the sun and the moon. Tidal forces and the gravitational pull of the sun, and then we have the moon on the earth. Now we say that equator what or north south movement, right? We have the equator what, or we be having the north south movement caused by the pole fleeing force. So we be having it is moving away from the poles, right? So we call it as the pole fleeing force. We have it as it is moving away from the force due to the gravitational differential force and the force of buoyancy to adjust to the center of the gravity. It is to force of the buoyancy, it is to adjust towards the center of the gravity, right? Equator what, and then we have the north south movement caused by the pole fleeing force. So we have the pole fleeing force is due to the gravitational differential force and the force of the buoyancy. So we say this is because of the gravitational differential force. Gravitational differential force, or we can also say that it is because of the force of buoyancy to adjust the center of gravity and the center of buoyancy. The westward movement caused by the tidal forces of the sun, and then we have the moon. Evidences by Alfred Wegener. Jigsaw fit. Jigsaw fit. And we'll be having the land reptiles. Glossopteris is a flower. Fossil remains are evidences. Structural changes. Stratigraphic evidences is analyzing the different layers of the earth. And fossils is Mesosaurus is a freshwater. Argentina and South America. Glossopteris is a fern which is found only in the colder climate, Eastern Africa and South India. It is not having a colder climate like glacier deposits. Tillite. Glacier deposits is tillite. The glacier deposit from the early ages is what we call it as a tillite. And placer deposits is the gold sediments. So tillite is a glacier deposits. Glacier deposits and placer deposits are the gold sediments. So we have the placer deposits. The placer deposits are the gold sediments, right? Alfred Wegener found the placer deposits of the gold on the eastern coast of the Brazil and the west coast of Africa. So Brazil is in South America and the west coast, the east of the Brazil and the west of the Africa. Exact impurities. No source of gold deposits in the Western Africa. Gold deposits in the Brazilian mountains only. There is no source of the gold deposits in the Eastern Africa. The gold deposits are only in the Brazilian mountains. Right. Alfred Wegener first evidence is the placer deposits, which he found on the eastern side of the South America, that is in the Brazil, and western side of Africa. Right. Now there is no gold deposits in Western Africa. Right. We need to say that there is no source of gold deposits in the Western Africa. Gold deposits are found in the Brazilian mountains. Criticisms. His assumptions that continents are floating on the ocean, that too without much resistance, and forces are not sufficient to cause the big movements. What is the condition before the why it was on the Carboniferous? Now let us see in detail. Evidences. Juxtafit. So we have juxtafits. Right. Juxtafix of the continents, that is similarities in the continents on the opposite side of the oceans. The continents are only present on the opposite side of the oceans, right? Structural evidences. Mountain belts of the Brazil terminates on the South American east coast, and same type of the mountain appears in Africa. Mountain in Africa and the Brazil, placer deposits which are found only in the mountainous region of Brazil, right? Stratigraphic evidences. Eastern coast of the Brazil has same type of the rock formations observed in the Western Africa. So stratigraphic evidences also tell about the eastern coast of the Brazil. Or with Brazil alone, we have first is the placer deposits. With Brazil alone, we have different kinds of evidences, right? The first one is going to be the placer deposits. So with Brazil, we have the placer deposits, and a second one is related to the mountains. That is the structural evidence. The structural evidence, the mountain built. Structural evidence is related to the mountain built, right? Now the third one is going to be the rocks. So the same kind of the rocks is what we have the stratigraphic evidence. Even the rocks are same. We have mountain belts which are connecting to each other. Apart from mountain belts, we also have that the rocks are also the same. Then we have fossil evidences of Mesosaurus is an aquatic reptile. The fossils remains were found in the eastern South America and South Africa. Had it been able to swim across a vast ocean, it would have been widely distributed. So Mesosaurus is similarly found in the eastern South America, and it's a reptile, freshwater reptile. It is an aquatic reptile, right? Mesosaurus. So we have the example of fossil evidences is Mesosaurus. Mesosaurus. Now, first evidence with juxtafit of the continents. Similarities in the continents which are present on the opposite side of the oceans. Structural evidence is the mountain, placer deposits, and then we have stratigraphic evidences. And after that, we are going for the fossil evidences. Is Mesosaurus is a aquatic reptile, an aquatic reptile whose fossil remains are found only in the eastern South America and South Africa. So it is an aquatic reptile, right? This reptile's fossil is found only in the aquatic reptile, and this reptile's fossils are found only in the eastern South America and South Africa. Had it been able to swim, if it were able to swim across a vast ocean, it should have been widely distributed. The fossils of Glossopteris. So then we have the fossils of the Glossopteris. Now we'll be having the fossil of a Glossopteris is a fern which is grown only in the subpolar climate are now found in the warm climatic zones which are separated by wide oceans. The fossils of the Glossopteris, which is a fern which is found in the subpolar regions. So the fern is found only in the subpolar region, right? The fern is found only in the subpolar climate. The ferns now it is found in the warm climatic regions separated by wide oceans. So it is found in the warm climatic regions. So it is found in the warm climatic regions, and the regions is separated by. So warm climatic regions, and the region is going to be separated by the oceans, wide oceans. Now glacial deposits is what we call it as the tillites is found in the warmer regions like India, Africa, South America, Australia. Glacier deposits is what we call it as a tillites. So the glacier deposits is tillites. Tillites. The glacier deposits is the tillites, which is found on in the. It is also found in the warm tropical regions. The tropical regions are Australia, South America, Africa, and India. Placer deposits is Brazil and Western Africa. Rich deposits of the gold without any source of gold nearby, but they are found in the Brazilian plateau. The criticisms is the rock of the continental crust and the oceanic crust are very rigid and would not permit the smooth drifting. There is no smooth drifting of the continents over the oceans. He mentions that there is no resistance, but what is the criticism? There is no smooth drifting of the continents. There is no smooth drifting of the continents over the oceanic floor. What is the criticism? The criticism is that there is no smooth drifting. There is no smooth drifting. So we can say that there is no smooth drifting of the continents. There is no smooth drifting of the continents over the oceanic floor. So over the oceanic floor, there is no smooth drifting. The geophysical mechanism envisaged for the movement of the continents, that is, the forces suggested, are inadequate. The theory did not describe the situations of the pre Carboniferous times. Buoyant forces will be having gravity, buoyancy. It will oppose the gravity is what will be having the buoyancy force, right? This is what continental drift theory is all about.